In this lesson, this is 7.2b continued on page 10. So in 7.2b, we talked about how you can divide radicals if they have the same index. In this part, we're going to talk about rationalizing the denominator. So steps for rationalizing is that you reduce the radicals if possible, and then you multiply top and bottom by the same number or variable, so whatever you do on the top is the same on the bottom, in order to make the denominator a perfect square or cube. For example, right here, I can't do anything with 5 and 12. If I were to put them into the same radical, 5 and 12 are not divisible, and 12 root x is not a perfect square. So I would like to make this one a perfect square. What could I do to it to do that? I could multiply the bottom by a 3, which would make this a square root 36, and that's a perfect square. And then I have this x. I could multiply it by a 3x. X times x would be x squared. This means that the bottom would come out to be 6x. And that's what I want. We want it so that there is no more radical in the denominator. But if I multiplied the bottom by root 3x, that means I also have to multiply the top by root 3x. And when I do that, I will get 15x, and that doesn't simplify down. If it would, I would try to simplify it. But then I just leave it with the square root 15x all over 6x. So if we take a look at some more examples here, rationalizing the denominator. This one here, root 5, what do I need to make this a perfect square on the bottom? And a perfect square would be something like 25. So I need to multiply the bottom by 5. And whatever I do on the bottom, I do on the top. Same number, always. So root 5 times root 5 is 25. Root 3 times root 5 is root 15. And then this becomes 5, and root 15 does not simplify. So it's square root 15 over 5. Same thing for this one here. What do I need on the bottom? A perfect square root could be 64, could also be 16. So if I could get a 16 and then let's say an x squared, I know those could come out as a 4x. What do I need to go ahead and to do that? I would have to multiply this by the root of 2x. Same thing on the top, same thing on the bottom. So I get square root 10x, 16x squared, 4x, 10x does not break down, so root of 10x. A little trickier when we start to throw in many different variables here, but again, just think about what do you need to get this to be perfect. So I could have 3 could go into the square root of 9. X squared is already perfect, but the y squared would need to show up as well. So what do I need to get from here to here? 3 times 3. X squared is already set, and then I need a y to make it y squared. Same thing on the top, same thing on the bottom. So I get 3x to the 5th y on top. On the bottom, it comes out to be 3xy. On the top, I can actually pull out part of these x to the 5th. So I can pull out an x squared, leaving me with root 3xy. So that's our rationalizing the denominator. If we look at 2 more examples, one with a cubed root in it, this one's a little trickier in that we now need a perfect cubed number. So we need to think about what's a perfect cubed number that we could use with the 4. And with the 4, we could do a 64. In order to get that cubed root, 4 times what to get 64? And this would be 16 here. And we'd have to have a y cubed, and I only have one y, so it needs to be a y squared. Same thing on the top, 16y squared. So we get 5 times 16 on the top, which is 80. So cubed root of 80y squared. This one comes out to be a perfect 4 and a y. Now this one actually, we could break this up into cubed root of 8 times 10 with a y squared. So this could actually become 2 cubed root 10y squared all over 4y. And now we could actually simplify a 2 and a 4 here. We could get cubed root of 10y squared all over 2y. If you have one where there's a plus or minus up top, that's okay. We still want to know what do we need to make it perfect. This would be the square root of 25. We end up getting square root 5 times square root 5. The biggest thing you need to watch out for here is that you need to think about this having parentheses and you are distributing inwards. So we will get 2 root 5 plus root 25, which gives you 2 root 5 plus 5 all over 5. I know some of you are going to be tempted to go ahead and cancel your 5s here, but you cannot because you need to have the same types of numbers front, back, and bottom in order to do that. So your final answer is 2 root 5 plus 5 all over 5.